Okay, good afternoon again to many of you. Thank you for coming. This is modules in one lesson. So I can't teach you everything about modules in one lesson, but my goal here is to teach you a fair bit to show you the essence of the module system as it actually works. Most of this will be live code rather than slides with pretty pictures and cool animations and stuff like that. So with that brief introduction, let's get going. As I go through this, if there are quick questions, feel free to raise your hand, and that might influence what I do, or I might ask you to wait until later. We'll see. All right, so I have here a very recent build of Jdk 9. This is in fact the Jake build. This is the jigsaw build that's in parallel to 9. This is the jigsaw code that we're actually working on actively, and occasionally we fold the latest changes into 9. There will be another one of those dumps for build 157 in a week or two. So I built this just a couple of days ago. It's got the latest module system changes in it. Before I dive into the module system, I actually want to show you a different feature. There are other features in 9 besides Jigsaw. How many people have played with 9? Not enough. Come on, guys. Come on. Okay, so how many people have heard of JShell? Okay, I know that only a few of you actually will have played with it, so let me show you quickly what JShell is. So JShell is a Java shell. You can type stuff at it, and it'll type it back. So it'll do tab completion. I can say, oh, give me the substring starting at 2. I can say substring starting at 42. And so on and so forth. So JShell's really cool. Check it out. It's got command line, history of functionality and completion. It's great. It's an excellent way to avoid having to write little x.java files in your IDE because you just want to experiment with an expression or a statement and figure out what it does. So as to the module system, so I've got the string foo. We all know we can get the class of an object, right? And this is going to say what? Java lang string. Well, we can now ask, what is the module of a class? As I was saying this morning, the module system, this module system is wired deeply into the platform. The language knows about it, the VM knows about it, the runtime libraries know about it. It's really deeply in there. So the string class, no surprise, is in the base module, java.base. Now that's a reflective object, so if we can ask what its class is. Whoops. And we find out that it's a class called Java lang reflect module. In the existing Java lang reflect package, there's a new class called module that is used to reflect runtime modules back up into the API, so you can inspect them and you can change them in certain ways and do other fancy stuff. So here we are, module system deeply wired in. Now you might be asking, okay, you did that, that's kind of cool, but I've got code that I wrote years ago and I lost the source code for it. I've just got a jar file. Will it run? Well, the answer is, it depends. If that jar file, or if your application, however it's packaged, doesn't use internal APIs, in most cases, doesn't use internal APIs of the JDK, then chances are really good that it actually will. As a demo, I have here swingset2.jar. Anybody remember swingset? Demo from back in the day when swing was a new and cool thing? So here's swingset2.jar from 2004, as shipped in Jdk 5 GA. So remember my Java command here. This is the latest jigsaw build. Jar, swingset2.jar. Ta-da! It works. Isn't that slick? Oh, swingset, I remember you. Those were such, oh, we got the kids. Yeah, these guys are in college now. Okay, so the module system is deeply wired in, but we've also gone to great lengths to keep the platform compatible. If you have old code that runs on the class path, doesn't use internal APIs, doesn't depend on rt.jar existing because it's gone, it should just work. If it doesn't work, please file a bug report. Okay, so let's look at some code. I will crank up my favorite IDE here, namely Emacs. So I've got a little tiny app here. It does hello world. Well, it does a little bit more than hello world. So inspired by a recent kerfuffle in the JavaScript community. Hello? Inspired by a recent kerfuffle in the JavaScript community, I decided left pad was an important example. If you don't know what this means, you can DuckDuckGo it and look it up. So I've got a package, org open JDK hello, main class. Got this little static method here, does left pad. You give it a string and a number, and it will pad that string on the left so that it is that long. And then dot, 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 dot. Public static void main string. It looks at its arguments. If there's an argument, there might be more. It takes that as an adjective and prints hello adjective world. Fascinating, I know. All right, so let's do the normal thing and just package this up. The classes, my really sophisticated IDE here. Okay, jar, create file. What did I call this? Hello. First, because jar is stupid. Okay, we do that. File libhello.jar. Dot. Okay, and then we can run java-jar. No, oh, sorry. Yeah. Org.openjdk hello main. Ta-da, hello world, way out there on the right. We can say bright. We can say wonderful. You can see the left pad is doing the hard work of computing the proper number of spaces. Okay, big deal. Mark, why are you showing me this? Well, so we've got this little application. Let's make it into a module. So to do that, whoops. Let me, what? Oh, that's weird. Pardon me while I clean up. Okay, so here's the source code that we've got. When writing modules, we introduce another level of indirection into the source tree because you might have a source tree that has more than one module. So what I'm going to do is rename source to hello and make a new source directory and move hello into that. Now if I tree source, I see I've got another level of indirection. And then we're going to put the module info.java file in that hello directory. So source hello module info.java. Okay, module hello. So remember the fundamental questions about a module. What does it require and what does it export? Well, what does hello require? The base module. Do I need to write that? Very good. You were paying attention this morning. I could write it if I want to, but it would be a waste of keystrokes, so I'm not going to. Does hello export any APIs for other modules to use? Nope. Okay, so it's like the world's simplest possible module info. All right. Let's redo that. I will compile it, and I can do this pretty much the same way that I did before. And here's what I have in my classes directory. There's main.class just like before, and then moduleinfo.class, which is a little class file as promised. We can ask it to type, yep, compile Java class data, version 53. We can run Java P on it. See what's inside. Ooh, requires java.base. See, the compiler did insert it. Even if maybe we didn't want it, we can Java P-v it and see even more detail. Whoa. So there's that. We can jar it up, make a modular jar file in the same way. Whoops, jar create. And there's the module info.class. And now we can run this as a module by saying module path is lib. No class path here, it's the module path. It's where we find modules, not random classes. Java module path lib, we tell it what module we want to run. It's hello. We need to tell it what class to run. Main. And there we go. So we've taken like the first baby step here. We've taken a simple hello world app and made it into a module. There's a lot of mechanism. There's a lot of stuff happening here, and I'll show you a bit more of that as we go on. Now, when I make that jar file, I can actually make my life more convenient. I can specify a main class. So this will be org open Jdk hello main. And now I don't have to type this. I can just run the module because it's got a main class, and that just works. And that main class information is actually put into the module info.class file, so it's understood by the module system. It's not just some thing sitting off the manifest. Okay, so that's what I will do going forward. Was there a quick question somewhere? No, okay. All right, so we've got the trivial hello module. We can run it on the module path. Oh, and since it's a modular jar, we can run it on the class path, maybe if you want. Of course, I have to say that because it's the class path. And I have to say that. But it works. It's on the class path or the module path, either way. And if I were clever and I compiled the main class to target 8 or 7, I could run this jar file unchanged on an early release, and it would work just fine. Okay, so now I'm going to refactor this sophisticated Hello World app into 2 modules. You could think of them as microservices, I guess. That would be buzzword compliant, would it not? Okay, so back into the IDE we go. We've got hello and its module info. What I'm going to do is I'm going to split main. Whoops, where'd main go? I'm going to split main. I'm going to put this complex left pad method into its own module. So let's call that module text, org open Jdk text, and we'll call the class patter.java. So, text. Take this method out, wrap a class around it. And there we go. Oh, I better make this public or otherwise it won't work. Yeah, I know. Shut up. Okay, I get it. Thank you. Public static. Okay, so to compile this, I'll need a module info for the text module. Now, this is going to be module text. Do I need to write any requires? No. Do I need to write any exports? And what should that exports be? org.openjdk.text. Okay. Good. Now I should go back to my other module info, the one for the hello module, and here I should write what? Requires text. Okay, this should all work, right? Oh yeah, hope so. Yeah, it should. Okay, so let's clean up here. We've got our refactored source tree. We can compile things. Let's do text first. And we jar it up. I'm going to make this quicker in a moment. Okay, so we make text.jar. We finally fixed it. Java-C, when you say -d classes, will go make classes for you, the classes directory for you. Jar needs that too. All right, so lib text.jar. There we go, our modular jar file with the pattern guy in it. Now let's compile the hello module again. Module not found, text. So, what's going on here? Well, I'm compiling the hello module, but I didn't tell it where to find the text module. And well, we require that. So we tell the compiler about that with the same exact option that we used at runtime, module path. And then that works. And we do a similar, whoops, let me redo this one. We create hello.jar. Now we've got our two modular jar files. We can now run, whoops, what am I doing? Mark, you're in the dark ages. Module path lib.module hello, right? Hello world. Sorry? Did you use the pattern from the main class? The pattern from the main class? The pattern. Oh, thank you very much. Duh. No wonder it worked. Oh. It's all a sham. Import org open Jdk text. I'll be lazy. Thank you very much for pointing that out. And let's see, it's pattern.leftpad, right? Yeah. Okay. We re-Java-C it. We re-jar it. We rerun it. I was not lying. Okay, so we've got two little modules. We've got a hello module, we've got a text module. All is right with the world. The runtime starts up, hello pulls in text, they both pull in java.base, things are great. So one of the main points I was trying to make this morning is the module system is about giving you reliable configuration and strong encapsulation, things that you don't get on the class path. So I'd like to show you a few ways in which things can fail and why that failure is actually a good thing. Okay, so first, well, we already saw this when I omitted text.jar. I just move text.jar out of the way here. Just move it up into the current directory and try to recompile hello. Well, I get a nice error message, module not found, text. Okay. If I try to run hello, so the hello module's there in the module path, I get a runtime error. Error occurred during initialization of VM. Module text not found required by hello, because, well, it's not there. So compile time and runtime, we detect the same kinds of failures and give the same kinds of error messages. This is the principle of fidelity between compile time and runtime is critical to making this whole thing usable. Sometimes they don't quite match, but they're really very close. Okay, let me move text.jar back into lib where it goes. So another kind of mistake one might make was, suppose I do this. And whoops, yeah. Package org open Jdk text is not visible. That's actually a bug. It should say not accessible, but whatever. And the compiler figures out, well, org open Jdk text is declared in the module text, which I see sitting right there, but hello didn't require it, so I'm not going to let it get at it. That's a good thing. Okay, let's put that back. Okay, so that's missing dependence. Another kind of failure mode is cyclic dependences. Cyclic dependences are really bad. If you have two components, two jar files and each one requires the other, that's a symptom of flawed design. I know there are a minority of people who really think cyclic dependencies are pretty cool and you should just accept them, but I think lots of software engineering experts I've read over the years have made a pretty good case that no, just admit it. If you have a cyclic dependence amongst components, they're really the same component. They're not multiple components, and you're just fooling yourself. So what if I go into the other module info and say requires hello? Okay, so recompile text. Now I have to say this. The compiler figures out cyclic dependence involving hello. Go fix your code. It's really one component. Through a sufficient subterfuge, you could actually try to get the runtime to do this as well, and it will give you a similar kind of error. So let's get rid of that and recompile. And whoops, rejar. Yeah. Okay, I'm gonna save some time here and just use the. I've got this handy command that does both the compile and the jar. It's called JJ, logically enough, and that will save us some typing time. So that's cyclic dependencies. Another kind of failure. What if a package is not exported? Maybe this pattern thing is actually an internal API, and you shouldn't access it. If I recreate the text module and now run the hello app, illegal access error. Class org OpenJDK hello main in module hello cannot access class org OpenJDK text pattern in module text because module text does not export OpenJDK org OpenJDK text to module hello. And this is not something that's just detected by chance in some library somewhere. This is the Java virtual machine. If you go read the code, it's the exact same pile of code that keeps a private method private and throws an illegal access error is doing this as well. It's all part of the VM. Now, I could also try to recompile hello, and the compiler gives a similar kind of message. Error, package org OpenJDK text is not visible, should say accessible. It's declared in module text, but it's not exported. So go fix your problem. Okay, let's put that back. So we've seen reliable configuration, we've seen strong encapsulation. What else can we see? Let's see, the missing export. Oh, here's a fun one, duplicate packages. Suppose, so we know that hello has a package called org OpenJDK hello. Let's pretend that text has it too. So I can do that. I need to go put something inside it. Public class I, yep, please create that. And now let's see, we will recompile the text module. We'll try to run this. Boom. The VM says resolution exception. Module hello contains package org OpenJDK hello. Module text exports package org OpenJDK hello to hello. You've got two packages conflicting, something that you would never be able to realize by inspection on a class path unless you go look at the contents, the complete content of every single jar file. And similarly, if I try to compile the hello module, I'll get a similar kind of error. Package exists in another module. Okay, that's an entertaining tour through various error messages. Yes? A default exports? Oh, just like default methods and interfaces? Let me get back to you on that. Maybe. Okay, so let's get rid of all this silly stuff here. Doesn't belong. Okay, now we're back to a clean state. Whoops. Oh. Okay, I think that's probably enough error messages for now. Let's move right along. So we've got our two modules. We've seen how the module system detects certain kinds of failures and prints useful diagnostics. What about the rest of the JDK itself? Let's take a look at that. We know that it at least has a base module, and I showed a pretty picture this morning of the rest of it. Here it is. Here is the Jdk Module Graph containing just the Java SE standard modules. There are a bunch of others that are specific to the JDK, but these are the ones that will be part of the official SE9 spec. Now, you can observe a few things about it. The base module, of course, is at the bottom. If you remember your graph theory from computer science, 102 or whatever, what can you say about this graph? What interesting property does it have? It's a DAG? Yep, it's a DAG. It's acyclic because, well, cycles are bad. So there are no cycles here. It's acyclic. There are a bunch of modules. Let me show you how that surfaces. So I've got this runtime here. I can ask it what modules are inside. Whoa, that's a lot. The whole JDK, there are 74 modules. Let me display those a little more conveniently. Now this should remind you a bit of the pretty graph that I showed. You can see there are a bunch of Java modules on the left, things named Java, those are standard. There are a bunch of modules whose names start with JDK dot, and those are specific to the JDK. You may or may not find them in other implementations. Many of these are for internal use. Some of them do export API packages, and they are supported for that purpose, but since they're not part of SE proper, they might not be available everywhere. So that's all the modules that we've got. So this morning I mentioned the possibility of linking. Java has a linker now. It's an optional step. You don't have to do it, but you can do really cool things with it. So to start out, I'm going to make a custom runtime image that contains just the base module. So I've got here's my JDK build in a handy variable. This jmods directory is full of jmod files. When you download the full JDK 9, you get a directory full of jmod files, which are all the jmods that were used to build that JDK. And of course, the JDK itself is built by JLink, just running on all of the modules. So I've got those jmods. I can run JLink. I tell it where my modules are, module path, just like before. I need to tell it what modules to include. I need to, since I'm only going to work with modules that are in the platform for now, I need to say add modules java.base, otherwise it would complain because it doesn't know what to do. And let's output that into a directory called JRE. Then it goes and thinks for a bit. If I look at the size of this, well, the JDK build that I've got is 556 megs. The JRE I just built now is 47. Well, that's kind of cool. I can confirm that it's got a Java command. I can list the modules in it, and it will say what? Java.base, only thing that's there. I can use this to run my Hello app. I give it the module path, hello. That's weird. I thought I did that. Oh, I forgot to give it here. Sorry. Okay, we do that, and it works. Okay, in this constrained environment, we can actually take a look at the operation of the module system. There's a handy option called xdiag::resolver. Will show you the activity of the module resolver as it goes. So we can see it started out, it got the root module hello from this jar file that we made. It found the text module because that was needed by hello, and that was in this jar file. It found base because, of course, hello needs it. Of course, text needs it too, and it had the resulting list. In some future version, maybe we'll actually have it generate a ping with a pretty picture or something. So that's the activity of what's going on at runtime. Now let's make another custom image. This time, I'm going to extend my module path to include our two little example modules, and I'm going to add the hello module. Let's stick that in JRE2. Now, if I run JRE in JRE2, I list the modules, and I see I've got hello, text, and java.base. The linker did resolution also and figured out, okay, you've got the hello module, it needs the text module. Of course, they both need base, so base gets tossed in there as well. And now I can run hello just like that. I don't need to give it a module path. It's all been baked into the image. I can go even further and make a launcher. And in that bin directory, there's now a hello command. Boom. So if you could imagine a bigger application composed of modules, make yourself a J-linked image. It only has what you need. Stick it in a Docker file, and off you go. One more cool thing. So we've got these custom JREs. Sure, they're a lot smaller than the full JDK build. Remember, I said the linker has optimizations in it. In particular, it has a bunch of optimizations for reducing space consumption. So let me make one more JRE. We'll call it JRE4, and I'm going to put in some magic options here. Let's compress all the class file data. Let's strip the debug information. And let's use a special VM called the minimal VM, which omits JVM-TI and other sorts of serviceability features in order to save some space. And I think it's only got one collector, and it only has C2, no tiered compilation. So we're going to make JRE4 here. Now this takes a while longer because it's doing a lot more work. I can look in JRE4. It's got the hello command. That still works. And it's only 15 megs. So that's pretty neat. Another cool thing about JLink is it can cross-link. This laptop's running Linux. If I had a Mac build of the JDK here or a Windows build of JDK 9 here, I could point the JLink that's running on Linux at that directory full of JMod files and make a custom image for Windows, make a custom image for Mac. Of course, they won't run on this machine, but you can still produce the image and ship it off somewhere else to be run. Was that a sigh of contentment? Glad you like it. All right. About 15 minutes left. Let me stop there with the demo part and consider a few frequently asked questions, one of which I got about an hour ago. There's the module graph. You might have various questions in your head, but what about this? But what about this other thing? So let me try to answer a few proactively. But how is the module path any better than the class path? I mean, it's just a path. You use the same directory, Mark. It was a directory full of jar files. Why is this any better? It's better because it's not a way to find classes. The module path is a way to find modules. Once the system sees that a particular artifact, a particular jar file is defining the module named hello, it will only look for classes for the hello module in that one artifact. It won't do some dumb thing of starting over at the beginning of the module of that list of jar files and going through them all until it finds the class that it needs, which is how you get all those nasty conflicts. Why does module info.java duplicate what's in pom.xml? The high level, this is actually a fairly deep question, and a very natural one. You look at module info.java, you look at the POM that would go with it if you were doing a Maven project, and it's like, gee, there's a lot of redundancy there. That seems painful. It is a little discomforting, but they are solving different problems. Module info.java is for the module system. Pom.xml is for a build system, which is, and they're solving related problems, but different problems. So it's okay that there's redundancy. It's a little bit unfortunate. I'm hopeful that over time, build systems like Maven, Gradle and whatnot will be more aggressive in how they support the module system so that there's less redundancy here. But for now, yeah, there's a little bit of redundancy. Where are the versions? So I answered this question in the Q&A session we had about an hour ago. We made a strategic decision after doing the first Jigsaw prototype, which did handle versions and all this kinds of fancy stuff. We made the decision to simplify and not solve the version selection problem. The main reason being that a bunch of existing systems like Maven and Gradle and Ivy and various app containers do this already, and if whatever we did, we would piss a bunch of people off because we would do something different than what they wanted, and it would be difficult to use. So we just said, no, we're not going to solve the version selection problem. A related question, which Nikolai asked, is, well, what if I really need 3 different versions of Guava? Well, if today on the class path you're using 3 different versions of Guava, your application is already broken, you just haven't figured it out yet. There is an advanced feature in the module system called layers, such that if you are willing to write a bit of code, you can actually load different versions of modules of the same name in the runtime system, and that they will relate to each other in sensible ways, unless you do something wrong. I just answered that one, didn't I? What if I need 3 different versions of the library? Use layers. What's wrong with cyclic dependences? I already answered that one. Why not just use OSGI? So OSGI is great if what you need is not just a module system, but a security layer and a dynamic lifecycle framework and a bunch of other stuff. It turns out not many applications need all that stuff. If you need it, it's great, use it. It runs fine on 9 because it's just above the platform. And we've done some work with some OSGI experts to make sure that OSGI and the platform module system, the Jigsaw and all this stuff can fit well together. So that's good. Fundamentally, we couldn't just use OSGI because OSGI is incapable of modularizing the platform all the way down. It was built on top of Java SE. We needed to go vertically, very, very, very deep down in order to achieve our goals of having strong encapsulation and also being able to modularize the JDK itself. If you think about it sort of like a philosophical error, you can't use something built on top of something in order to modularize the thing that you just built on top of. All right, we've got about 10 minutes left. A little more information. There are all these JEPs. This is the same slide I showed this morning. We could do some questions if there are questions. Please wait for the mic.
Hello, I'm wondering if you can have multiple module files.
Multiple module files? How do you mean?
Like if you put in your base directory a file which said module dash something. Could you have multiple of those, and how do you solve it? Or do you just say you can have only one?
By convention, you can have only one. There can be only one. And it's called module-info.java or .class. You could write more module declarations and stick them in other files of different names, and they'll be there, but the module system's not going to look at them.
Cool, thank you.
Well, my question, if you're on code, you use several modules that require the same module or something, what will happen? I mean,
If several modules use
So,
the same
for
module,
example,
then, well,
if I-
they'll all happily share that one module.
so it will be shared. But
Yes.
what if they have the same name, but it's just a name conflict? So,
Well, they can't have a conflict, right? So the module path, when the system is looking for a module on the module path, it looks in each directory, it looks at each artifact, it finds the first artifact that defines a module of that name. If it finds more than one artifact in a single directory that defines module of the same name, it stops and it says, you have a problem. You need to figure out which one of those you mean, because I'm not going to do version selection for you. Make sense?
What about SPI? Will the runtime service provider interface, will it still be able to access, the factory will still be able to access the implementations regardless of
Yes.
exports?
Please come to my talk tomorrow.
Yeah, okay.
So,
Thank you.
so the service lookup mechanism has been enhanced and integrated with the module system, so that services are something that the module system understands. And if you think about it, it has to, because if a service is provided by some module, resolving that module might require resolving some additional modules, because that module requires some others that you don't have yet. So services are understood by the module system, and I'll talk more about that tomorrow.
Thank you.
They're a key tool for modularizing the JDK itself, or really any legacy code base, because services basically allow you to express what you might have wanted to express with a cyclic dependence, but in a much cleaner and safer way.
Support by ID and build tools like Gradle and Maven, for example.
Sorry, what's the question?
What is the status?
What is the status?
Yes.
We've been working actively with the maintainers of both Maven and Gradle to make sure they have solutions to their problems, they understand what they need to do. If you know, Robert Schulte is the chair of the Maven PMC at Apache. I spoke with him just a couple days ago at FOSDEM about some latest issues we've been working through. So Maven already supports, I don't know what release line you need to get, but Maven already supports doing builds of modules. Gradle has actually supported it for a somewhat longer time. There's initial support in Eclipse and NetBeans, and I think now IntelliJ for all of this stuff. But it's still, it's still shimmering some, because the module system is still shimmering a little bit as we finish everything up and get it buttoned down.
So if you have multiple modules that export the same package, am I correct to believe that we can't do that anymore? We have to be more exact in having separate packages in separate modules.
Yes, you could throw multiple modules into a directory in the module path, and they might all export the same package. That would be fine. But as soon as the resolver looks at them, if the resolver needs to load more than one, then it will detect a split package conflict and refuse to proceed.
Okay, thanks.
More questions?
About the linker, does it do any kind of tree shaking to reduce size?
No, the linker does not do tree shaking. For those who aren't familiar with the term, tree shaking is a very deep optimization, and it's called tree shaking. As you think of, well, okay, I've got a tree of code, and I know only some of that code is used, so I take the tree and I turn it over and I go like this, and all the code that isn't used falls off. It's a term of art going back to Lisp and Smalltalk in the 60s. No, there's no tree shaker. There could be, but there isn't. It's not that sophisticated yet. It is nicely integrated with the ahead of time compiler prototype that's in Jdk 9. There's a question up here, if the mic is, and there's another one here. Somebody in the back?
Yeah. What is the license of the linker output, the JR created by the linker?
I should put that on the FAQ list. What is the license of the linker output? Can you redistribute that? Well, if you did your own build from OpenJDK, then go read the GPL and figure it out. If you got an Oracle JDK build, Oracle's intent is to make it possible for you to redistribute modules that you link together. We have, one of my colleagues has on his to-do list, and he knows there's a deadline coming up, namely the GA release, to work with the legal team to get the fine print all worked out. But we believe it's straightforward. It shouldn't be a problem. That's the intent.
What if you have two modules with the same private packages? Can you have that? That are not exported?
Good question. Two modules with the same private packages. Here we run into a fundamental limitation of the way class loaders work in Java. You cannot have in a single class loader more than one definition of a package. So if you're just using the application loader, what you get by default, and you're loading up a bunch of modules from the module path, if two of those modules have the same unexported package foo, then it will fail. Now that's not a failure of resolution, that's a failure at the class loader level, but it will be detected. If you are in a situation like that and you can't avoid it, then that's another opportunity to learn about the layer API. With layers, you can load things into different class loaders. There's even a convenience API. If you want to be really safe, you can load every module into its own class loader so that there's no chance of these private package conflicts.
Hi. At the beginning, when you showed us the output of the error messages when you omitted the text export, the error message, it said something like text isn't exported to hello. Mm-hmm. It sounded a little bit like it could be exported, but just not to hello. Was that just how that message was phrased, or is there a way to target your exports to specific audiences?
Excellent question. So there's an advanced feature, which I will show tomorrow. You can qualify an export. So the declaration of the text module could have said, exports this package to hello, in which case hello could access it, but no other module could. So yes, that error message is phrased that way to be most general, because sometimes there are qualified exports. We use, by the way, qualified exports are essential for old code bases. We use them all over the JDK. Those JDK modules have some interesting intimate relationships where the base module exports a secret reflection thingy off to the Corba module, and it's hairy, but it works.
Hi. Say I do a class 4 name. Will that be limited to the requires of the class that calls it, or is it anything that's available in the VM?
Somewhere in between. So the class loading is fundamentally unchanged by the module system. So if you load a bunch of modules into the application class loader, what you get by default, then any one of them can do a class.4 name on any class in any of those other modules. Now, so you'll get a class object back. You might not be able to do anything with it because you won't have access to those actual types. And if you try to use reflection to instantiate something, you'll get an illegal, inaccessible object exception or something along that lines. But visibility, the way the class.4 name works is essentially unchanged. We have about a minute left. Last question.
So when downloading the JDK, will I be able to cherry pick which modules to build my JDK from?
Well, you could do it by hand, or you could just let JLink do the work for you. That's kind of the whole point, right? If you know you only need, say, the base module and SQL, then you could run JLink and say add modules java.sql. It'll figure out that you also need logging in XML, and make you a custom image with just those things. But if you wanted to list them out all by hand, you can do that too. And if there's still any missing, JLink will add them because it just interprets the module graph and does the right thing. All right. Okay. Thank you very much.